Okay class, welcome back. Today we are going to touch on a topic of percent yield. In this lecture we are going to combine several topics in which we have learned in prior videos and units. My objective for you today is that you'll be able to calculate the percent yield and measure the efficacy of a chemical reaction. In saying that, let's dive into what we got. In chemistry, sometimes reactions do not go according to plan. Sometimes the amount of product produced differs each time you repeat the reaction. In our prior lessons on stoichiometry, we have calculated the optimal amount of product using our mass-mass problems. This optimal amount of product formed is our theoretical yield and represents the maximum amount of product that can be produced from a given reactant. Whether it's because a faulty measurement, equipment errors, or environmental influences, the amount of product we produce in a reaction is rarely the same as the theoretical yield. The actual yield is the amount of product we actually produced when a reaction is completed. It is important to know the difference between both the theoretical and actual yield for a given reaction. By knowing these, we can calculate how effective our chemical reactions were. The percent yield of a product is the ratio of the actual yield to the theoretical yield, expressed in percentage. In other words, it is the actual yield divided by the theoretical yield, then multiplied by 100 to create a percent. The closer the percent is to 100%, the closer the actual yield is to our theoretical yield. This means the closer to 100% our percent yield is, the more optimal conditions we have provided for our reaction. So let's work a practice problem with this. Solid silver chromate, Ag2CrO4, forms when excessive potassium chromate, K2CrO4, is added to a solution containing 0.5 grams of silver nitrate, AgNO3. Determine the theoretical yield of silver chromate and find the percent yield of this reaction if it yields 0.455 grams of silver chromate. First thing we got to do is to think of the chemical equation and balance it. Since there are two compounds in this equation, is going to be a double replacement reaction and should read, once balanced, 2AgNO3 plus K2CrO4 yields Ag2CrO4 plus 2KNO3. Now we must solve out for our theoretical yield in this reaction. We have 0.5 grams of silver nitrate and we want to find how many grams of silver chromate is produced. This is nothing more than a mass-to-mass problem. So to get the grams of silver nitrate to moles of silver nitrate, we are going to have to multiply 0.5 grams of silver nitrate by 1 mole of silver nitrate over the formula mass of silver nitrate, which is 169.9 grams. This gives me that there is 0.00294 moles of silver nitrate. Now, we multiply that by the ratio, so 1 mole of silver chromate over 2 moles of silver nitrate. This gives me 0.00147 moles of silver nitrate. For the last step, we are going to multiply our moles of silver nitrate by our molar mass of silver nitrate, which is 331.7 grams per mole. This gives me 0.488 grams of silver chromate that we can produce from our 0.5 grams of silver nitrate. So this is going to be our theoretical yield. Now to find a percent composition, all I have to do is take my actual yield, which is 0.455 grams of silver chromate, and divide it by my theoretical yield, which we calculated was 0.488 grams of silver chromate. I then multiply that by 100 and I get 93.2% silver chromate. So my percent yield once again would be 93.2%. Okay, that's all I got with percent yield. I hope this video showed you the steps you need to solve percent yield problems and the process that you might have to go through to prove the efficacy of a reaction. Remember, keep up the good work in the class and see you next time.